growing. Factor, a scenario like that, Joe, how about common denominator? All right. And looking back here. All right. Okay. How about this scenario? Nine minus x. By the way, sometimes the author uses t's, sometimes the author uses s's. I just don't want to use s here because s can look like a 5. So I'll use x. And he's got something like this, a 9 minus x, 3 minus the square root of x. Find the limit as x approaches 9. This one is like number 27. It's like, I'm doing like 30. It's like number 27. I'm trying to see if there's another one like it. That's the only one? I'm shocked you didn't get 2 of these, Joe. The only one is like 27. That's it. And this one's like 27. And don't worry, like even tonight, if you try 27 tonight, because I put it as a practice problem, and you don't get it, let's do that one tomorrow. I always like to let you kind of play with it first. All right, plug in 9, what do you get? All right. We gotta manipulate this dude. Now, there's one way that works every time with this scenario. Because you might look at it and go, it might not look factorable to you, because you don't see the typical x squared minus 9s. We may come back to that, okay? Because some of you may prefer that. But I'm going to look at this problem, and I want to give you a technique that's new. Factoring, all right, maybe I'm not aware of how I can factor that. Doesn't look factorable right now. We'll come back to that. Common denominators. Can't done work, right? I don't see any fractions. But multiply a conjugate. Have you ever done that before? So I'm going to add that to a list. It's another strategy. It works definitely in that scenario. Joe would work on number 27. Multiply what we call a conjugate. What's a conjugate? It's simply the opposite. And you go, of which part? And when you got this guy and you got this one, multiply the conjugate of the radical. How about that? She said bottom. I like that because you saw that pick in the bottom. Look to see where you got the square root. How about that? Identify where the square root's hanging out and multiply the conjugate of that expression. So this word conjugate, what's the conjugate of 3 minus square root of x? Now the only thing is I got to do it on the bottom and the what? Top. Now here's what I want you to do. Leave the top alone. Alright? Leave the top alone, leave it as is. I don't want to we're not going to make this problem as difficult, more difficult than it is. It's the bottom. We wanted to make the bottom pretty. Focus on the bottom, where you did the conjugate. That's where you need to focus. Foil that thing out. F-O-I-L. And what happens? When first, outers, inners, last. F-O-I-L, right? What happens to the oid? They just go away. Because look, when you do the first, you get the 9. You do the outers, you get plus 3 squared root of x. You do the inners, you get minus 3 squared root of x. Bye-bye. And then the L is that minus what? Square root of x times square root of x is just a x. And a lot of you just do that mentally. So you have to write all this stuff, which is great. So I'm going to rewrite this so you all see it. 9 minus x, 3 plus square root of x. It's all over 9 minus x, and we get to cancel the what? Now it's done. Take it and what? Put it in. What's 3 plus square root 9? Now you may want to investigate this. Look at that graph with your calculator. You'd probably see it approaching a 6. The only danger is sometimes graphs like that may look a little weird. Just because of the nature of how it's set up. Conjugate. So we got our list is grown, but that one doesn't go further than this. One more type. Cool. Conjugate. Now does everyone have this? because I want to back it up. And I bet you some in this class have another idea and it works. You sure? Yeah? All right, back it up, back it up, back it up, back it up, back it, come back here. Did anybody have another idea?
Is it like 9 minutes?
I heard it, what was it?
Just factor at the top.
He goes here. What's funny is that when you look at that and you go, factor, they don't put those problems in algebra books, but you can factor it. See, I mean, how do you factor this? Just tell me, how do you do that difference of squares? It's x plus 3 and what? X minus 3. It just doesn't look like something. Absolutely, you can factor that. Watch what he's going to do. He's going to factor this dude. Da-da-da, da-da-da. It's a difference of perfect squares. Square root of 9 is just a what? 3. Make one a plus, make one a minus, but what's the square root of that thing? Root x. So feel free on the test. You like that better? You might find that quicker? You're like, psh, I'm done. Plug in the number. No one say that? So here, just so you're okay then, how would you factor that thing right there? If you wanted to.
4
Da-da-da, as a difference of perfect squares. 4 minus a what? Root x, and a 4 plus a root x. I know, they don't put them in algebra books. But we can get the calculus to let you see that. But you definitely can factor that. Great call. Yeah, I don't need to play with that conjugate. Okay. Oh, finally, when I get to grab a problem that's actually in the book because it's even. This is number 30. All right. So you can write that number 30. Let's do that one. The limit as x approaches -4. Here's our repertoire of things to try. Square root of x squared plus 9. Boy, I wish we could simplify that, can we? No. Can't simplify that thing. -5 over x plus 4. This stuff's fun. Well, let's substitute the number. Let's see what we get. If we get a actual finite number, we're going to put that as our limit. So 0 over 5, 0. 5 over 0 does not exist. What do you get?
Wait, isn't the square root of x squared plus 9 just x plus 3?
I wish. You're thinking of this. I wish. You're thinking of that. Which is what? They got a list of like the most common misconceptions in math. Do you know that's number 1? It is. See, that's x plus 3.
Yeah.
It's actually the absolute value of x plus 3. That's just can't simplify. Isn't that funny? Unless you're in a complex number system, I'm with the i's. You're doing x plus 3
But if
I.
you split the two, if it's the square root of x squared plus the square root of 9.
I wish we could do that. We can't. I know.
The conjugate on the top.
Yeah. That's gonna work. That's gonna work. Great call. So let's try the conjugate. You hear him? Let's do the conjugate at the top. I do want to point out though, it looks like you can simplify, but you what? You can't. Hey, it's number 1 on the list of what? Students' misconceptions of some expression. That's number 1. They look at it and go, you can make that x plus 3. And you're like, nope, I wish, but nope. This right here does not equal what? X plus 3. You wanna just let's easily show why. Use the number like 1. I want to put a 1 in there. Is the square root of 10 equal to 4?
No.
See, there you go.
Okay.
There you go. He's like, it doesn't work. Very good. But then when I heard an idea, look at our list, factoring, common denominator, conjugate, he goes, go with conjugate. Great idea. The conjugate of which one? The top. He looked for the radical. And he saw the radicals up here. Oh, it's going to be long. Who cares? Just make it long. Square root of x squared plus a 9 plus a 5. Now notice I didn't change that plus in there. So let's see that. Just that guy. And what else do I go to on this bottom? Oh, it's going to be long. Now I want to say this over and over, emphasize this. Leave the bottom alone. Everyone, you got me? Leave the bottom, don't go foiling out the bottom, you'll make a mess. It's the top you're trying to what? Prettied up. You're hoping you get the top all prettied up and it knocks out that x plus 4. Alright, here we go, FOIL. What's x squared plus 9 with a radical on it? And another root x squared plus 9. What's going to happen to the outers and then the inners?
Every side.
They're just going to cancel. So when there's the F of FOIL, the O and I are going to do what? Cancel out. We know that happens every time in the conjugate. So get to the L. It's minus 5 times a plus 5. Alright, we get all this all over what? There's an x plus 4. And there's a square root of x squared plus 9 plus a 5. In the parentheses, we are not going to FOIL at the bottom. What's the top simplified to? Let me write this again. Limit x approaches 4. Limit x approaches 4. X squared minus 16. Daggone it, that's still, give me 0. And when I'm still in the indeterminate scenario. But I bet you know what to do. And I'm still in the indeterminate scenario. Ugh. Any suggestions? Now you factor, look. Isn't that cool? We went from here, now we're coming back to here. Factors the top. X plus 4, x minus 4. Boy, we're going to get an answer now. There they go. Opsh, opsh. You got this what, x? We never... So where do students get lost in here? I grade tests. I see students, they know to multiply the conjugate, right? The error is they start expanding the other thing without the radical. They start foiling it all out, and it gets crazy, and then they can't cancel anything. They get to here, there's nothing to cancel. So now, what are we going to do for our last step?
Professor,
Oh,
that should be minus for limit
oh,
x.
you're the best. Where is that? Right
X,
there?
Yeah. No, x, limit x approaches minus 4.
Oh, right there?
No, limit x approaching 4. It should be negative 4.
Right there?
No, on the other left, limit.
Limit as x approaches negative 4.
Oh, thank you. Thank you. You guys are the best. I wonder, like, that wasn't a 4, that's a negative 4. Hey, thanks. So now, let me write this again. The limit as x approaches negative 4, and you got a x minus 4. The bottom has a square root x squared plus 9 plus a 5 with a big old hat on there, right? So what happens when you plug in negative 4 at the top? We get negative 8. And how about the bottom? That's an ugly looking radical, I apologize. It was only the first part? So when this radical here is only here, yeah, that would have made it irrational. And you get 16 plus 9, 25. The square root of 25 is 5. The 5 plus the 5 is the... So there's our numerical answer. Can we reduce it?
Negative 4/5.
Nice. There's your limit. There's your limit. So there's our list.
That's it. Like I said, there's
Nah, there's one more.
I understand, there's 4.
There's 4. So when I'm going to one like number 17. Okay? So, let me put this up here. This one, everyone, like number 17. Because I want you to practice 17. The answer's in Bob. Bob is back a book, right? Yeah, Bob, I have the answers, you can check it. So let's make one, just kind of, don't go too far off, but something kind of cool, all right? First of all, I noticed they used the letter H. Okay, I'll use H. So when as H approaches a 0, they got a negative 4 plus H squared. They got a minus 16 all over H. least I can't mess that one up, Art. This is just 0. Negative 0 is 0, right? Thanks again, everyone. Okay. Well, the first thing we do is we plug into what?
0.
Plug into 0. Well, I'm going over here. Factor, common denominator, conjugate, so what's another way? We just expand it. And what do I mean by expand? Multiply everything out. Let's try that. There we go. Well, how about that? Yep. Get rid of that square and just expand it all. So what do you get if you expand it? 16. Oh, first I should write it like negative 4 plus h. Negative 4 plus h. All right. $16. Negative 8h plus a squared minus so far so good? Anything go out?
Cancel out the 16.
Nice eye. Ah, they go away. Oh, now we're safe. I mean, I'm still getting 0 over 0, indeterminate form, but I think you know what to do. Factor out the h. See, we're getting 0 over 0 now, but they're like, factor out an h. Get this h, get this h, you get negative 8 plus h. Substitute what number?